Have you ever just stopped and thought that reality feels a little weird? Like the rules don't always add up? Well, here's a thought. What if those strange rules aren't bugs, but actually features? Today, we're diving deep into that very idea, the simulation hypothesis, but we're looking at it from a really unique angle, through the eyes of a game developer. And that right there is the heart of what we're exploring. This whole idea comes from somebody who literally builds virtual worlds for a living. And when you do that, you have to create rules. You run into limitations. And when you look at our universe with that mindset, some of the weirdest parts of physics suddenly stop looking like cosmic mysteries and start looking a whole lot more like clever programming. Now, before you write this off, let's be super clear. This isn't some fringe conspiracy thing. The simulation hypothesis is actually a serious thought experiment. You have physicists, philosophers, and top-tier computer scientists genuinely debating it as a way to test the fundamental nature of our reality. So that leads us to the big question for today. What if all the things about physics that make you just scratch your head are actually elegant solutions to the massive challenge of running a simulation as big as our universe? What if we're not discovering the laws of nature, but actually just reverse engineering its source code? Okay, so to see why this idea is so compelling, we first have to really appreciate just how strange the rulebook for our universe actually is. Let's take a look at a few of the big ones that have had scientists stumped for over a century. First on the list, the speed of light. I mean, think about it. In a supposedly infinite, real universe, why should there be a speed limit at all? Why can't you just keep accelerating forever? It feels totally arbitrary, doesn't it? And this isn't just a suggestion. It is an absolute, unbreakable law. Almost 300 million meters per second. Nothing that has any mass can ever reach it. It's like the ultimate speed limit, just hard-coded into the fabric of reality itself. But why? All right, our second rule is where things get even weirder. Down at the quantum level, the universe, it seems to know when we're watching it. The simple act of observing reality literally changes what reality is. How is that even possible? This is the famous wave-particle duality. So an unobserved particle, like a photon of light, it just exists as this vague cloud of possibilities, a wave. But the instant you try to measure it, bam, it snaps into a single definite location, acting like a particle. It's as if reality waits for an observer before it bothers to, render all the details. And for our third bizarre rule, we have to talk about time itself. We experience it as this constant, universal river flowing for everyone at the same rate. But Einstein proved that's just an illusion. Time is absolutely not the same for everyone. It's a concept called time dilation. Basically, the faster you move through space, the slower you move through time, at least compared to someone standing still. It sounds like science fiction, but we've proven it with incredibly precise atomic clocks on jets and satellites. But again, in a base reality, why would time be so flexible, so personal? Okay, so we have these three deeply counterintuitive rules, right? A cosmic speed limit, reality that seems to render on demand, and this weirdly flexible time. But now, let's put on our game developer glasses, and all of a sudden, these bugs start to look like absolutely brilliant features. Let's start with the speed of light, C. For a game developer, an absolute speed limit isn't a mystery at all, it's a necessity. It's basically a processing cap. You can't let a player move infinitely fast because the game engine needs time to calculate and load the world ahead of them. So the speed of light might just be the maximum processing speed of our universe's computer. And what about reality changing when we look at it? To a developer, that just sounds like a standard optimization trick called level of detail, or LOD. I mean, why waste precious computing power rendering every single leaf on a distant mountain that the player can't even see? You only render what's in the player's view. Quantum mechanics might just be the universe's ultimate LOD system, only bothering to render a particle's exact state when an observer finally asks for it. And time dilation? Oh, from a developer's point of view, that's not a bug. It is a stroke of genius. It's a lag compensation mechanism. If a player starts moving close to the system's processing limit, the speed of light, you just slow down their internal clock. This gives the simulation more cycles to load the world around them. So from the player's perspective, the experience stays perfectly smooth, even at insane speed. These analogies are already pretty convincing, right? But the developer's perspective gives us another clue, and this one might be the most powerful of all. What if space and time aren't actually smooth and continuous? What if they're made of tiny, indivisible units? What if our reality has a screen resolution? In real physics, this idea actually exists. It's called the Planck length. It is a distance so unbelievably, mind-bogglingly small that, as far as we understand, it is the shortest meaningful length there is. You literally cannot measure anything smaller. So what does that really mean? It implies that our universe isn't infinitely smooth. It has a fundamental minimum resolution. And for a developer, a system with a minimum resolution is just a system made of pixels. The Planck length. It could literally be the pixel size of our reality. And you know what? This exact same principle also applies to time. If there's a smallest possible distance, well, there has to be a smallest possible unit of time too. We call this the Planck time. It's the time it takes for a beam of light to travel just one Planck length. And what is the smallest possible slice of time in a simulation? It's the time between each tick of the processor. It's the tick rate of the game engine. The Planck time could very well be the fundamental frame rate of our universe, the frequency at which the entire simulation refreshes itself. So when we step back and put all these pieces together, a really clear pattern starts to emerge. The absolute weirdest, most head-scratching features of our physical world, they suddenly seem logical. They almost seem obvious when you look at them like a programmer. And that's really the power of this hypothesis. It takes this collection of what seem like random, absurd, unrelated rules that govern our existence, and it reframes them into a single, elegant set of solutions to the technical problems of computing an entire universe. So let's just recap really quickly. The cosmic speed limit, that becomes a processing cap. Quantum mechanics, that becomes a rendering optimization. Time dilation, a form of lag compensation. And the discrete, chunky nature of space and time, well, that's just the universe's resolution and its frame rate. The bugs really do become features. Now, of course, this doesn't prove that we're living in a simulation, but it does leave us with a pretty fascinating and maybe even unsettling question. When our physicists are probing the deepest mysteries of the cosmos, are they discovering the fundamental, eternal laws of a base reality? Or are they just reverse engineering the clever workarounds and elegant code written by the developer of our universe?